Find the Laplace transform of 2t squared e to the negative t minus t plus cosine of 4t. So through linearity, we can separate all the major independent variable t terms, and we can bring out the coefficients of 2 times the Laplace of, we can rearrange it so that it's e to the negative t times t squared. It's always good to bring out the exponential term in front of the independent variable. And we can separate the minus Laplace of just t, and lastly add the Laplace of cosine of 4t. So let's look at the property of the first term, where Laplace of e to the at times f of t in the time domain will equal capital F, now in the Laplace s domain, of s minus a, where a is the exponential coefficient. In our situation, we have Laplace of e to the negative 1 times t, so 1 is our coefficient, times our f of t, which is t squared. And as we know, a equals negative 1. That means that our f of s term will become f of s minus now a, which is negative 1. Or in other words, f of s plus 1. So whatever we find for our f of t Laplace, we just have to add 1 to every s term. So for our t to the n power, where n equals 2, we can make our second Laplace property, where the Laplace transform of t to the power of n, where n is any integer, equals n factorial over s to the n plus 1, where n equals 1, 2, 3, and so on. So for our term, we have Laplace of t squared. This is our f of t term, where n equals 2. So that simply equals 2 factorial for n over s to the power of 2 plus 1, which equals 2 times 1 over s cubed, which equals 2 over s cubed. Now this is our f of s term. We need to convert it to f of s plus 1. So all we do, again, is just take any quantity s and add 1 to it. So in this situation, we take our s, turn it to s plus 1, and make sure the entire quantity is cubed, not just one of them. It has to be any time there's an s appearing, and since there are 3 s's being multiplied by each other, you have to cube the s plus 1 term. Now over here, for our second portion of the equation, we have Laplace of t. And fortunately for us, since we already wrote this property, we can just use it again. So Laplace of t to the 1 power will now equal 1 factorial for n over s to the power of 1 plus 1. So just simply 1 over s squared. And that's it for that term. Lastly, for our cosine term, we have to understand the Laplace property of cosine, where we'll call the coefficient of t b for any integer. And this equals s over s squared plus b squared. So from our equation, we have Laplace of cosine of 4t, so you can already tell b equals 4. And all we have to do is plug that in. So now it's s over s squared plus 4 squared. And that's everything we need. Plugging it all in, don't forget the 2 on the outside that we have over here as our coefficient. You're multiplying that by your f of s plus 1. And don't forget to subtract our Laplace transform of t, which was 1 over s squared. And lastly, to add our Laplace of our cosine term, which was s over s squared plus 4 squared. You can also write 16, it doesn't really matter. It's just nice to keep it in proper formatting. And simplifying, we get our final answer of 4 over s plus 1 cubed minus 1 over s squared plus s over s squared plus 4 squared. And that's our final answer. I hope this video made sense. If it did, please like and subscribe, and I'll see you in the next one.